My kids love playing red light, green light, so like any good parent, I thought, how can I automate this? Enter the Arduino powered automatic red light, green light game. The game uses a passive infrared sensor to detect motion and lights up green LEDs for a random amount of time to tell you when it's okay to move forward. When you need to stop, it lights up the red LEDs, and if the sensor detects motion while the red LEDs are lit, it sounds the alarm and you lose the game. So to let your kids play, you just need to set this up on one side of the room and have them start on the other side of the room and see if they can make it all the way to the Arduino without getting caught. In the rest of this video, I'll show you how to build the circuit and how to program it. Now, to show you how to do this, I'm going to be using Tinkercad Circuits, which is a free online circuit and Arduino simulator that runs in your web browser, so you can either create an account and follow along in Tinkercad, or you can follow along with a physical Arduino. But in Tinkercad, I am going to create a new circuit, and you can click and drag components out from the menu over here on the right. So I'm going to add an Arduino and a breadboard. And if you don't know how a breadboard works, that's kind of a topic for a separate video. I can provide a link in the description. But the nice thing about Tinkercad is that when you mouse over the holes in the breadboard, it highlights the other holes that are connected. So the breadboard is just going to allow us to easily prototype the circuit without soldering. And again, Tinkercad will show us which holes are connected. The very first thing I'm going to do here is connect the Arduino's power and ground, so 5-volt and ground pins, to the breadboard's power and ground buses. So just like with physical wiring with a real Arduino, it's important to keep your wiring neat in Tinkercad so things don't get messy and are easier to debug. So I can click to route the wires and then drag these handles to relocate them. That is going to keep things a lot neater than just wiring point to point like this. A lot of times when I see students do this in Tinkercad, they just have a web of green wires crossed all over each other because they're just making them straight. But if you route them around like that, again, it's much easier to see. You're also going to want to color code them, so I can click on a wire. I'm going to change my ground wire to black, and then when I add the 5-volt wire, I'm going to change that to red. So I have my breadboard set up to share power and have a common ground with the Arduino, and now I'm ready to start adding components to my circuit. Now we're going to add our first hardware component, the PIR sensors. So PIR stands for passive infrared. These sensors have 3 pins, a power pin, a ground pin, and a signal pin, which is a digital out. Most of these sensors are active high, meaning they are going to output 0 volts when they don't detect any motion, and 5 volts when they do detect motion, which they detect by detecting infrared light or body heat. So to wire this sensor up to the Arduino, the physical sensors are going to have these male header pins, so you can use male to female jumper wires to connect them to a breadboard, or like you saw earlier in the video, you can just put these pins directly into the breadboard. I am going to wire all 3 to the breadboard like this, kind of like I would be doing if I was using those male-female jumper wires. So again, black for ground, red for power, and then I'm going to pick some other colors, say, I don't know, green for a signal. And then on the breadboard, I'm going to connect the power pin over to 5 volts, again, staying consistent with my color coding, the ground pin to the breadboard's ground bus. And then I am going to pick an Arduino pin to use for the signal. Doesn't matter which one, things are going to get a little messy later as we connect a bunch of LEDs and a buzzer, so maybe plan ahead. I think I'm going to plan ahead to reserve pins 2 through 7 for my LEDs. In general, you want to avoid connecting things to Arduino pins 0 and 1, since those are also used for serial communication and can mess up uploading your program depending on what you have wired there. So I am going to go ahead and connect my sensor's output pin to Arduino pin 8. And again, to keep my color coding consistent, I'm going to turn that wire green. Now, a common theme throughout this video, rather than wiring everything all at once and then writing the entire program and running it, we are going to wire and test things one at a time, because one of the problems with building a complicated circuit and writing a more complicated program is that you go run it at the end and it just doesn't work, and you're not sure why. You have to backtrack and identify and isolate these subsystems, or find out which component is causing the issue, or if there's a certain section of your code that's causing the issue. So again, when building a more complicated circuit like this that has a lot of parts, it's good to kind of test things one at a time as you add them to verify that your hardware is working before you implement more complicated logic in your code to get everything working together. So, opening up the code, Tinkercad defaults to a block-based programming environment, but we are going to hit this drop-down menu, switch over to text, and then I'm going to make the text a little bigger so it's easier for those of you who are watching on YouTube to see this. And it defaults to your basic blink program to blink the built-in LED, but we don't need that, so we are going to delete those and keep just our Arduino setup function, which is going to be our setup code that only runs once, and our loop function, which is going to be our code that loops forever. So I'm going to change my comment here to Arduino red light, green light game. And the first thing I'm going to do is set up two variables to allow me to use this sensor. I'm going to tell the Arduino which pin I'm using. So const, because that isn't going to change. That's short for constant. Int, and you can call this variable whatever you want. I'm going to call it sensor pin and set that equal to 8 since I have my sensor plugged into pin 8. And then I'm going to create a pin for the sensor state, which I will call, create a variable for the sensor state, which I'll call sensor state. And variable types are a topic for a different video. It's kind of overkill to use int here because this is really just a Boolean variable that's only going to be high or low, but many intro Arduino tutorials you see just for simplicity's sake will use int, so maybe I'll do another topic on different variable types in the future. For now, we're not going to worry about that. So we have declared our two variables up at the top. In our setup function, we need to tell it whether we want that sensor pin to be an input or an output. So I'm going to use the pin mode command to tell it I want the sensor pin to be an input in all caps. I am also going to set up serial communication here. So serial.begin 9600, that's the baud rate. Because I don't have any hardware outputs, I have not wired my LEDs yet, so I just want to print out to the serial monitor whether or not my sensor is detecting motion. Down here in my loop function, so again, setup, that's my code that just runs once at the beginning. I don't need to do that over and over. In my loop function, I am going to use polling, which means I'm just continuously checking the input every time the loop iterates, similar to how you would poll a button, to monitor the sensor state. So I'm going to set my sensor state variable, sensor state equals, and I'm going to use the digital read command. So digital read sensor pin, and that is going to return high or low or true or false, whatever you want to call it, depending on whether that pin is high or low. But I don't just want to read it. I would like to maybe print out some message or let me know whether the sensor is working. So the easiest way to do that is just to do a serial print of that variable. So I'm going to do serial print sensor state, close parentheses, semicolon, and now you would be ready to upload this code to your physical Arduino, but in Tinkercad, I'm going to hit the Start Simulation button up here. And in the physical Arduino IDE, you would need to go to Tools, Serial Monitor to open your serial monitor. In Tinkercad, there's just a button here for it here at the bottom, where you can see I'm just printing out a giant line of zeros, which reminds me that I actually wanted to use serial.println, which is going to print to a new line instead of printing it all horizontally. So I'm going to clear my serial monitor, start my simulation again. If this was a physical Arduino, you would re-upload your code. And you see now I am printing out a big vertical line of zeros. So clearly this is a simulation in Tinkercad. This is not actually detecting motion, but Tinkercad allows me to click on the sensor and then move this little imaginary ball around in front of it, where you can see that the output then changes to 1, and these little LEDs on the sensor light up to indicate that it's detecting motion. So in real life, sitting there with your physical Arduino and PIR sensor, you would want to wave your arms or hands around in front of the sensor and confirm that it is detecting motion and your output is changing. You will probably notice that these sensors are extremely sensitive. They are designed for use in security systems and things like motion-activated lights, and they have an extremely wide field of view. They're designed so you can just mount one on a wall and it can cover an entire room. So if you find that it is too sensitive, it's going to be a little too hard for your kids to play the game, you could try restricting the field of view by putting something like a cardboard tube over it. You may also want to check the datasheet for the specific sensor you have, or look on the back to see if there is something like a potentiometer or a pair of jumper pins that will allow you to adjust the sensitivity to make it a little less sensitive and harder to trigger. Okay, so we have verified that our PIR sensor is working. The next step is to add some outputs. So we're going to add some LEDs, and at minimum, you just need one red LED and one green LED. I added more to my circuit just to make it a little more visible, but I'll show you how to do all three here. So I'm going to first line up 6 LEDs on the breadboard. Use the copy and paste function here in Tinkercad to get 6 of these. So I'm going to do 3 red, and then I am going to change this next one to green and do 2 more greens. Line these all up in the breadboard. Again, talking about how a breadboard is wired, it is important not to put the LEDs in the breadboard like this because the holes in a single row are all connected. So if you wire it like that, you are short-circuiting the 2 legs of the LED to itself, and it's not going to light up. So important to make sure that the 2 legs of the LED are in 2 separate rows. And then you need a current limiting resistor in series with each LED so you don't burn the LED out. 220 ohms is a good value to use with the 5-volt Arduino logic. So I'm going to do a 220 ohm resistor in series with each LED to the ground bus. So again, I'm going to need 5 of those. Copy them in. No, copy and paste only does one at a time. Sorry, 6 of those total. 1 for each LED. And then, after I have each LED, notice that I have the short leg, the cathode or negative side of the LED going to ground. And I am going to do jumper wires from my Arduino pins to the longer leg, anode, or positive side, whatever you want to call it. So again, I reserved pins 2 through 7 for this. I'm not going to use pins 0 through 1. I'm going to route my wires neatly. And even though I'm using red for positive, I'm also going to go ahead and use red for my red LEDs here. The color of the wire does not affect the functionality. It is purely to help you keep track of what you're doing. Going to route my wires to the positive legs of my LEDs, and then I'm going to switch colors and use green wires for my LEDs. If you are intimidated by this or don't want to just start out with one each, one red and one green LED, then that'll keep things a little neater. But the wiring for all of these is the same. Again, it's a output pin from the Arduino to the positive side of the LED, and then you have the cathode or negative side of the LED going to the ground bus. Now, switching back to our code, we would like to program these LEDs as outputs that react to the PIR sensors. So, getting some better comments to my code here, we have pins for PIR sensor. Now we're going to add a section for LED pins where I'm going to declare const int and call these whatever you want or whatever makes sense to you. I'm going to call them, for example, red 1 is going to be pin 2. Red 2 is pin 3, and so on. So you could change the naming here depending on how many LEDs you have, but note that the number of the LED does not necessarily correspond to the physical Arduino pin because I didn't start the LEDs on pin 1. So green LED number 1 is on Arduino pin 5, and so on. Green 2 is on Arduino pin 6, and green 3 is on Arduino pin 7. In my setup function, I am now going to need to declare all of these as outputs. Now, I could have maybe done this a little neater by using an array and then a loop, but arrays and loops are topics for different videos, so I'm just going to copy and paste the same line of code a bunch of times. So I'm going to have pin mode, red 1. This time I'm going to be declaring that as an output, and then I'm going to copy and paste that line of code 5 times, and then just change the name or number of my pin here. So red 2 and red 3 are also outputs, and green 1, green 2, and green 3 are also outputs. Again, could do that with arrays and loops to avoid having 6 lines of code there to basically do the same thing, but we are keeping this simple and not really talking about arrays and loops in this video. The next thing I would like to do is change my loop so the LEDs are reacting to the state of the sensor. I want, say, green LEDs to be on by default when no motion is detected, and then the red LEDs to light up when motion is detected. And that is not fully programming the actual red light, green light game yet, but again, remember the idea is to sort of test as we go along here to make sure my LEDs are working. So I'm going to add an enter here after I read that center state. And now I'm going to use an if-else statement. So I'm going to write if. I'm going to have my condition for the if statement, open curly brackets, close curly brackets, and I'm going to say else. So what am I going to do if the code for that if statement is not true? And to fill in my condition for the if statement here, I'm going to make that if sensor state equals true. And note that this is a double equals sign, which is the comparison operator, as opposed to the single equals sign, which is the assignment operator. And I just remembered that I'm actually going to write equals high there, not equals true. Sorry about that. Again, those terms kind of get used interchangeably, but depending on the programming language, you may need to use a specific version. In the Arduino, it needs to be sensor state double equals high. So this is going to say if my sensor detects motion, I'm going to do something here. Else, if my sensor doesn't detect motion, I'm going to do something here. And I'm going to move my serial print statement inside the if statement. So I'm going to have two different options here. Rather than just printing out the name of the variable, I'll say something like motion detected. And if I'm not detecting motion, then I will print no motion detected. But I also want to light up my LEDs, which I am going to do with the digital write command. So again, if I want to detect motion, this is kind of like a very basic alarm that turns on the red LEDs when it detects motion. That's going to be digital write red 1, high. And then again, could do this with arrays and loops, but instead I'm just going to copy and paste that line two more times. I'm going to turn all of the red LEDs on, and if no motion is detected, I'm going to turn all of the green LEDs on. So change this to green 1, green 2, and green 3. So now if I hit start simulation, or you upload this code to your physical Arduino, initially with no motion detected, my green LEDs should be on. It's printing out no motion detected. And then if I simulate detecting motion with the PIR sensor here in Tinkercad, it should switch to printing motion detected and turn on my red LEDs. But you might notice a problem there. It did not turn off the green LEDs. And then if I stop, well, now it's saying no motion detected again. But now all the LEDs are just staying on. And that is because in my code, I never told it to turn the LEDs back off. It turns the green LEDs on immediately when no motion is detected, and then the first time it ever detects motion, it turns the red LEDs on, but it never turns them off again. So to get the behavior I actually expected there, where the red LEDs are only on when motion is detected, and the green LEDs are only on when motion is not detected, I need 3 more lines of code in each part of my if-else statement here to turn the opposite LEDs off. So I need red 1, red 2, and red 3 to go low here. I'm going to do low, low, low. And then I'm going to add the same thing for the green LEDs up to the first part of my if statement here. Oops. Green 1, green 2, and green 3 are all going to go low. Okay, now if I run that, or you re-upload to your physical Arduino, I should see what I expected, where not only is the output in the serial monitor correct, but my LEDs also correspond to red when I'm detecting motion, and then back to green when I'm not detecting motion. The final bit of optional hardware you could add here is a buzzer. Now, I personally hate the sound of these buzzers. I find it very high-pitched and annoying, but it does sort of help with the game to also have an audible warning, especially when the LEDs transition from green to red, kind of as an indicator you need to stop. So I will show you how to do this in this video, but you can feel free to omit it from the project. So it's labeled piezo. In Tinkercad here, there are a bunch of these little buzzers you can buy. Be careful because there are 2 different types called active and passive. The passive ones require that you use the Arduino tone command and allow you to adjust the pitch or frequency of the buzzing sound. The active ones just use a digital high or low and only produce a single pitch. So I believe the one in Tinkercad is active and can be controlled just by digital high or low, but we will find out when I run the code here. So you can see it is just labeled, it is polar, it has a positive and a negative. I'm going to pick a different color like blue for my buzzer, and I'm going to wire one of the Arduino pins to the positive and then the negative pin to ground. And then in my code, I'm going to go ahead and just add a buzzer pin, so constant buzzer pin that is on pin 9. In my setup function, I'm going to also set my buzzer pin as an output, and then in my loop, I'm going to add, oops, wrong copy paste, 2 more digital write lines to set my buzzer pin high along with the red LEDs when motion is detected, and set it low when motion is not detected. So now if I upload this, again, I didn't test this before recording, so I'm not sure if the buzzer here will actually do anything in Tinkercad, but I have no motion detected. And when I detect, oh wow, it actually does make sound come out of my computer speakers too. I don't know if my mic was picking that up at all, but it did give a little animation on the buzzer there to indicate that it was on. So again, if you test that with a physical buzzer and it doesn't work, that probably means you have a passive buzzer, not an active buzzer. You can just go Google the Arduino tone command and replace these digital writes with tone to set the buzzer to a different frequency. So at this point, we have basically made an alarm. It's not really a red light, green light game yet. It just turns the red LEDs and the buzzer on whenever it detects motion. But the point of doing all that was, again, to verify that our hardware is working before we have a more complicated program that gets trickier to debug. So if you have everything working at this point, you have verified that your input, the sensor, and all of your outputs are working okay, just with a very simple program that just has this simple single if-else statement logic, again, confirming that your outputs can react to your input. Now we are going to change gears a bit to writing a more complicated program that is effectively going to disable or ignore the PIR sensor input while the green LEDs are on. So if you're a human playing the red light, green light game, pretend my mouse is the human for a second, that means it's okay to move forward while the green lights are on, but then when the red lights turn on, we are going to monitor the PIR sensor input and only set off the alarm if we detect motion while we're in that state. So I'm going to show you how I go about doing this. This isn't necessarily the only way or the right way, but it works and makes sense to me. So first off, one of the key things about red light, green light is that the lights are red and green for a random amount of time. This makes the game unpredictable and is how you get caught if you run forward too far or kind of jump the gun when the lights are red. So we are going to create a handful of time variables to make it easier for us to make the lights red or green for a random amount of time. So I am going to make a variable called green time. That's going to be the amount of time that the lights are green. And I am going to set 2 constant variables for the minimum and maximum amount of time that the lights can be green. And then later I will use those as the range for a random number generator to set that time. So I'm going to call those green min, and I'm going to set that to 5 seconds. And green max is going to be 10 seconds. But again, you can tweak these parameters depending on your kids or the size of the space where you're playing or whatever. And then same for red. I'm going to create a variable called red time. And then I'm going to give that 2 minimum and maximum values. So red min 1 and red max, say I'll make 5. So I have the time range for the lights being red is lower than the time range than the lights being green. That makes the game maybe a little less on the frustrating side or easier for younger kids because you get more time to move forward before the lights turn red and then the lights don't stay red for as long. Next up, my setup function doesn't really need to change. That is still just setting all my inputs and outputs. but I am going to need to do something different in my loop function. So rather than deleting all the code in my loop function, I'm just going to do a big block comment using the slash asterisk and then asterisk slash to kind of comment this out. But then if I ever need or want to revert to just a basic state to make sure all my hardware is still working, in case the logic for my other code gets more complicated and I get sort of confused, I can come back and uncomment this just to get back to that basic state, or save this as a separate program and then start a new program with this as your base, and you could delete this if you don't want your code to be as messy. But for now, I'm just going to leave it there with a block comment. So here is kind of the logic or the structure of what I want to happen in my loop function. I want to pick 2 random times, so I'm going to set my green time to a random number. I'm going to use the Arduino random function to do that. And if you can go look up the Arduino random function for this, it just accepts a minimum, max, and maximum argument and will generate a random integer between and including the minimum and the maximum -1. So if you want it to go all the way to your maximum, you actually need to do green max plus 1 here. So that way I will actually get a potential maximum of 10 instead of 9. And I'm going to do the same thing for my red time. I'm going to use the random function between red min and red max plus 1. Now, this is where the code gets a little trickier. I now want to wait for red time seconds, but while I am doing that, I want to monitor the pin connected to the PIR sensor to see if it changes and I detect motion. But I can't just do another delay for red time because, well, the code is hanging in that delay. It's not going to be able to use digital read or detect a change on this pin. It's going to wait until the delay is over. So one way to get around that would be to use something called an interrupt, which is a separate function that can monitor a change on a pin and interrupt the main loop, even if you're in the middle of a delay. But we're not going to go over that. Interrupts are maybe a topic for a different video. Instead, I am going to use an approach where I measure elapsed time and use a while loop instead of using a delay command. So to do that, I am going to need 2 new variables that I forgot to declare earlier. So I'm also going to have a variable called current time and one called elapsed time. Okay, and after this kind of mercy delay, when I've called my stop function, I'm going to set current time to millis, which is an Arduino function that measures the elapsed time in milliseconds since the program has started running. I am then going to initialize my elapsed time variable to 0, and then I am going to have a while loop, and the condition for this while loop is just going to be while elapsed time is less than 1,000 times, red time. So this while loop is, the condition is going to be true, while elapsed time, which is going to start counting up from 0, is less than my red time times 1,000 for milliseconds. So this loop will keep executing until elapsed time exceeds that value, which is I'm then going to want to stop monitoring the PIR sensor and change my lights back to green. So, while I am inside this loop, this is where I'm going to do my polling for the sensor state like I was doing previously. So I am again going to have, I can actually copy and paste some of my code that I had earlier. Copy that. I am going to set my sensor state variable to read the sensor pin. And if I want a debugging line in here, if I'm testing this while connected to the serial monitor, I could again have that serial print line sensor state, and then here is where I'm going to check, forgot my semicolon there, if sensor state equals high, then I'm going to want to trigger my red LEDs and my buzzer. So I am also going to write, as you saw at the beginning of the video, a separate function to flash the LEDs and the buzzer instead of just turning them on, and I'm going to give that function an argument to tell it how many times I want it to flash. So again, we will write that along with our stop and go functions after we finish the main loop here. And again, if you want to have a serial print in there for debugging, you can have something like motion detected. Okay, and then I am going to end my if statement there, so I don't have an else. It's just the if, And then the important last thing I need to do here is I need to update my elapsed time. So I'm going to set at the end of the loop, elapsed time equals milliseconds minus current time. And oops, current time is a variable, not a function, so I didn't need the parentheses there. I also forgot my semicolon here at the end of this line. And I'm realizing that maybe a better name for this variable would have been loop start time or something, because I'm just measuring that current time once before the while loop starts. It is not really getting updated continuously, unlike the elapsed time, which is updated at the end of each iteration of this while loop again. So when I get back to the top, it's going to check the condition again and see if this elapsed time has become equal to or greater than this quantity in parentheses here, in which case it's going to break out of the loop. But if the sensor, this way, if the sensor detects motion while it's in this while loop, it's going to flash the alarm indicating that you have lost the game. So that is the main logic here. Let's go through that one more time. I'm going to select random amounts of time for green time and red time. I'm going to do the equivalent of saying go or green light, which is to turn the green LEDs on and sound the buzzer briefly. I'm going to wait while not monitoring the sensor. This is when it's okay for the player to move forward, so it doesn't matter if the sensor detects motion. I'm then going to call my stop function, which is the equivalent of yelling red light. I'm going to sound the buzzer briefly and turn the green LEDs off, turn the red LEDs on. Give that bit of mercy delay to give, the inertia of the human body some time to actually stop. But then I'm going to effectively start a stopwatch, and while that stopwatch is running, I'm going to monitor the sensor for motion. Once I have then reached my red time variable, that is going to end. I'm going to stop monitoring the sensor. I'm going to come back to the top of the loop, pick 2 new random times, and repeat the process. So we have that all set up, except now we need to actually write the go, stop, and flash functions. So first up, we are going to do our go function. I'm going to scroll all the way down outside of our loop function. So this is a separate function, and this one does not really return anything or take any arguments. So I'm just going to put int go void, and then fill in what I want this function to do inside the curly brackets here. So when I say go or green light, I want to turn the red LEDs off. Remember earlier in the video when we just turned the LEDs on by setting pins high, then we had the problem where after the first loop, the other LEDs didn't turn off. So even though all the LEDs are off initially, it does not hurt to effectively turn them off again when they're already off. They're just going to stay off. So I'm going to have red one low, and actually I could just copy these lines from here rather than typing them all out again. I'm going to turn my 3 red LEDs off and turn my 3 green LEDs on. I am also going to just briefly sound the buzzer. So my indentations are getting a little messed up here as I copy and paste these lines. But say I could have something like digital write buzzer pin high. Then I'm going to have a very short delay, say 100 milliseconds. Again, I hate the sound of those buzzers, so you probably don't want it on for very long. And digital write buzzer pin low. So it's going to toggle the LEDs, turn the reds off, the greens on, and then beep the buzzer real quick, and then the go function is over. It's going to jump back up here and wait for 1000 times green time before calling the stop function, which we're going to write next, which is going to be very similar. So I'm actually just going to copy and paste my entire go function, but I'm going to change the name to stop, and then I'm going to switch the highs and lows on the LEDs. So now I'm going to be turning my red LEDs on and my green LEDs off, and then I'm going to keep the code for the buzzer at the end the same, because I still am just going to briefly beep the buzzer when I say either stop or go. So there we go. I've got my stop and go functions, and finally I just need my flash function, which again is sort of just a bell and whistle. You could just turn the buzzer on and leave it on or something awful, but I thought it was nice to flash the LEDs when you get caught. So this one does accept an argument. So instead of void, I'm going to have int flash int n. So it's going to accept an integer as an argument that is passed to the function. And then I am going to use a loop. I know I said in here the loops were a topic for a different video, so kind of explaining how exactly this works is, again, a topic for a different video. You can just copy what I have for here. I'm going to have a for loop that says for I equals 1, I less than or equal to n, I plus plus. So that's just going to count a index of I up from 1 to n, and then do the for loop for each value of that index. And I'm just going to flash the LEDs, so I'm going to have digital write, and I'm going to copy my code to turn my red LEDs on here, instead of typing it all over again. I'm going to turn all 3 red LEDs on, along with my buzzer. Copy that. Wait for some short amount of time, say maybe 250 milliseconds, and then I'm going to copy all of that and turn everything low. So you can play with the number of iterations when you call this function. If I want to flash them 5 times instead of 3 times, I would make that a 5 here. And if you want to change the speed, you can change these delays. I do need to change all of these to low first. This way, if it detects motion, while it is waiting in stop or red light mode, it will flash the LEDs and repeatedly sound the buzzer indicating that you have lost. So I am now ready to simulate this in Tinkercad. So if I go ahead and hit Start Simulation, I should see that the green LEDs turn on for a random amount of time. The buzzer did flick there at the beginning. It switches to the red LEDs for a random amount of time. And as long as the PIR sensor does not detect anything, the red LEDs will just stay solid for a random amount of time until it goes back to the green LEDs and sounds the buzzer again. If the PIR sensor detects motion while the green LEDs are lit, nothing happens. However, if the sensor detects motion while the red LEDs were lit, then it's going to call that flash function and flash the LEDs and pulse the buzzers. So that was a little fast. Maybe I will stop the simulation and actually slow down that delay in the flash function so that's a little easier to see. Run the simulation again. So again, nothing happens when the LEDs are green, but if it detects motion after the red lights are on, then it's going to call the flash function, turn the buzzer on, and flash the LEDs 3 times. The final thing I considered adding here is a button to push when you win the game. So again, thinking of physically having this set up on one side of a room where your goal is to walk from starting on the other side of the room all the way to the Arduino without setting off the alarm. It would be nice if once you get close enough, you can push a button to indicate, hey, I'm here, I won, and then maybe flash the green LEDs to indicate that you've won. But I decided not to do that because I have a 4-year-old and I did not want my kids touching the breadboard because the components probably wouldn't have stayed in place for long if the kids were touching it or messing with it every time they played. So clearly, if you were going to build a nicer case for this or solder the components instead of just slapping on a breadboard, maybe that would be a little sturdier and more feasible. I opted not to do it for this prototype, but if you did want to do that, you could take the same approach that I used to monitor the PIR sensor here during the stop phase to monitor the input for a button during the go phase. So rather than having this delay 1000 times green time here, you would have another while loop measuring elapsed time being less than 1000 times green time. And in that loop, you would monitor the state of the button. And then once the button is pushed, you could write a separate flash function to flash the green LEDs to indicate that you've won. And you could add more things, for example, measuring the total elapsed time to complete the game. So you could have a start button, maybe a delay to give the person to walk back to the other side of the room, and then start measuring time until they push the button so you can see how quickly they can beat the game. Tons of other potential things you can add here. I am not going to go through all of them in this video though. So if you've made it this far, I hope you enjoyed this and found it helpful. I do have a bunch of other Arduino and electronics tutorials on my channel, so please go ahead and check that out. And leave a comment below if you tried this project yourself, and let me know how it goes. Thanks for watching.